Hello everyone. Welcome to the next lecture on the numerical analysis. Today we will cover about what is the Newton's backward interpolation formula. I will explain this lecture with the help of the 10 numerical examples. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of numerical analysis. In this playlist you can see the various lectures related to the interpolation like Lagrange, Newton divided, Newton forward and many more available in this playlist. You can subscribe my YouTube channel so that you can get the notification when I upload my next video. Now, what is the objective and what is the goal of this lecture? Whenever you have some sort of the informations like x and y, then my objective is how you can find the polynomial fx which fit these points. For example, if I say my information is x values are 40, 50, 60 and so on, the corresponding value of the fx is this. Can you find the polynomial of the x so that when I substitute the value 40, you will get the 204 and so on. So this is my objective number 1. Second objective is once you will fulfill the objective 1, how you can find the polynomial values at some point, like how you can find the values at the point 42 because 42 is not given to you. How you can find the polynomial values at the point of 93 or at the point of 84. Fine. So these are the objective, and for that purpose Newton backward difference applicable. Remember that in our last lecture we have achieved to learn how you can solve the Newton's forward interpolation, and that you can easily find at my YouTube channel, and the title of this is Newton forward interpolation. What we have learned in this lecture, that means when this method is applicable only when we need to find the value at the start of the information. Like you can see 42 is lies near to this information, near to the starting of the table. So this value you can compute by using Newton forward interpolation formula. However, you can see that 82 is very far away from the start of the information. So in that case, Newton forward formula is not so appropriate, but you can use, but not so appropriate as much as for the 42. So now in order to come, because the 84 is near to the backward, so that's why we are applying to use this Newton backward difference. So that means what will happen if you are interested to find the value which are near to the data. That means like of 84, like of 95, like of 78 and so on. For that case we are using the Newton backward difference formula. The overview, the objective is similar to the Newton's forward formula. So I must recommend you must watch about my this lecture in order to understand this lecture very easily. Now remember that the Newton backward difference formula is also called as the Newton formula for the backward interpolation. Make sure this formula is applicable when you have the equal interval. What is the meaning of the equal interval? That means x1 minus x0 is say h, then x2 minus x1 is also h, x3 minus x2 is also h, and so on. That means the difference between these points is same. Now the backward difference formula is denoted by this nebula. This is called as nebula. Always remember that once we have studied the forward difference formula, which is denoted by this triangle. However, the backward difference is denoted by this term. I call this as my nebula. Then how you can define that? The first backward difference formula is defined because it's a backward. We can start from this backward side. Nebula of yn is the difference between the yn and its previous value yn minus 1. Similarly, you can find the backward difference formula for the y1 is y1 minus y0. Backward difference formula of the y2 is y2 minus y1 and so on. If you want to find the nebula square of y2, for example, that means this 2, that is the meaning of the difference. You can define call as the first backward difference formula. Why we call as the first? Because you can see the power is my 1. If you want to find the second backward difference formula, we call as the delta 2. That is a first divided difference of the 1 minus of this. Now, the first objective is how we can obtain the polynomial. That's the most important objective of this lecture. Now, since we have each of the xi's are my equidistance, that means x1 minus x0, x2 minus x1 all are my same. Then we can define the polynomial corresponding to this information start from the backward point. That means a0 is the constant, a1 x minus x1, a2 x minus x1, xn minus 1 and so on. Now we can compute these polynomial values at the point of xn, xn minus 1 and so on. What will happen at the point of xn? If you substitute the value of the xn in equation number 1, what is the value of the fx? This is my yn, this is a0 plus a1 xn minus xn plus a2 xn minus xn into xn minus 1 and so on. Clearly say this quantity is a 0, this value is 0. So the only quantity which is left behind is yn is a naught. Similarly, we can find the values at the point of x is xn minus 1. Your fx will be y of n minus 1. a0 is your yn, a1, this is my xn minus 1. And at the point of xn minus 1, this value will be 0 and so on. Similarly, we can find the values at xn minus 2 and so on. Now, since we already obtained that x0, x1 minus x0 is my h, so that means this difference, the difference is also h. This, now you can see the difference is my twice. So I call this is my 2h. Why? I can written xn minus 2 minus of xn. Can I write this quantity as of this manner? I can add and subtract xn minus 1 on this side. So what is the value of this? This is my h, this is my h, that will be my twice of h. Similarly, again you can see this is xn, this is xn minus 2, the difference is twice, so I call as a 2h. You can see the difference is 1, so this is my h. So I can substitute this value. We can obtain, this is my a naught, this is my quantity h, this number is my 2h, this number is my 2h into h, so that is a 2h square. So from this expression, can you find the value of a0? Can you find the value of a1 and so on? So clearly say from this number I can obtain the value of a naught, that is a yn. Yn is nothing but fx. Can you find the value of a1 from this expression? I can substitute the value of a naught, this is the yn minus 1 over h. And you know what is the definition of this case? That is the nebula of yn. Fine. So I can obtain the value of the a1 in terms of nebula. Can you find the value of the a2 from this expression? This is yn minus 2 minus a naught plus twice a1h divided by twice of h square. I can substitute the value of a naught, which is nothing but my y of n. I can substitute the value of the a1. a1 is my yn minus 1 over h. H will be cancelled out. So this expression, I can open this value. It is yn minus 2 minus 2 yn minus 1 plus yn divided by 2h square. I can break this yn minus 2 into the 2 times. Clearly say this is my nebula of yn and this is nebula of yn minus 1. And I call this is my del square of y. Similarly, you can find for the other quantity. I can substitute all these a0, a1 and a2 in the expression of this polynomial. So you will get this is my required polynomial. Now, because this formula looks like a very tedious, I can simply choose u is my a minus xn divided by h. Why I taken as xn? Because we are using the backward difference formula. So you can see this quantity is my u. I can write this number also. This is my xn. I can add this is xn of xn minus 1. So I can substitute this value. You will get this is the required polynomial of this backward difference formula. Now, once we can obtain this Newton backward for the polynomial, then my target is how you can find this value. So I will tell you the simple 3-step rule. The first step is we will define the difference table. Now, if you think about that, how you can write the difference table, the same way as I defined in the step number 1 of the forward interpolation. Second, we can find the value of the u, and then we can write the Newton backward formula. But if you remember that this formula is a very complex in form, but how you can remember this formula? I will explain you this with the help of the numerical example. Now, look at the first numerical example. Your target is to find the value of the f of 84, which is lies near to the end of the information. Fine. So if your information is lies 84 lies near to the end of the information, we can apply the Newton backward interpolation formula. So what is my step number 1? You have to complete this. Your target is to complete this table. How you can complete? Very simple. You can find the nebula of y. That means the difference of this. Again, you can see each are my equidistance. So once they are my equal distance, so you can see the Newton backward formula applicable. So what is the difference of this? The first difference is my 20. I can write this difference 20. Second number 246 minus 224. That is my 22. Then you can find the difference of this 270 minus 246. That is my 24, and so on. You can complete this table. Because all the values are not same, we can find the second divided difference. I can subtract this quantity. This is my 2. Always write the difference in between them. This is my 2. This is my 2. This is my 2. Now, since all these informations are my same, so I can stop computing the next table. So you have to compute the differences until you will get a single number or you will get a constant quantity. Now, once we know this all information as a constant, then we can start with the value of the u. My target is to compute at 84. So my x is 84, xn is my last number, xn is my 90. What is the common difference? You can see the difference is my 10. So the answer is minus 0.60, sorry, 6 over 10. That is my 0.6. So value of the u is my minus 0.6. So now I can apply the Newton backward difference. So remember, whenever you are using the backward difference, we are using the last line. How you can remember this formula? So clearly f of x, which is equal to, first case is my a naught, that is the value of the y at the end point. Always remember, this is my x0, this is my x1, this is x2, this is x3, this is x4, this is x5. So the last number is my y5 plus u times of the first divided difference. It's a del square. I can write as a u plus 1. If it is a del cube, then you can write as a u plus 1, u plus 2 over 3 factorial. Then it's a very simple. What is the value of the u5? That's the last quantity, 324. The value of the u is minus 0.6. Del of u is the last value, 28, plus u is my 0.6. It is my minus 0.6 plus 1 over 2 del square. That's the last value is my 2. Then you can use these numbers, and now you can use the calculator. You will get the right answer as 306.96 is the right answer. You can also check your answer in the examination. How you can check your answer? Because our target is to find the value at 84, which lies between 80 and 90, and your answer must lies in between them. Now look at the second example. Again, you can see the difference is my 0.4, 0.4, 0.4. They are equal distance, and your target is to find the value 1.6, which is lies in the middle of the information. But in the given statement, they are asking you find the backward difference for. Now, can you complete your target? Firstly, find the difference. What is the difference between 4.82 minus 3.49? So that will be 3.1. So it's a 1.33. Similarly, you can find the second difference, 5. 96 minus 4.82, the difference of this quantity 411, so it's a 1.14. Similarly, you can find the difference between 6.5 and 5.96. It is my 4, it's a 14, 5.54. Fine. So this is the first. Now since all the values are not same, so we can find the second divided difference. I can subtract them. 1.14 minus 1.33. So I can subtract 1.33. So that will be 9.1. So it's a minus 0.19. Similarly, you can subtract the 0.54. Again, you can see they are not same. Then I can find the del cube. What is the difference of this? Minus 0.6 plus 0.95. So that will be my 41. So minus 0.41. Now since you have obtained a single number, so your target is complete. Then your target is to find the values of the u x minus xn over h. Can you know? Let me know what is the value of the x. X is my target value. Xn is my last number. What is the h? The difference between them, that's the 0.4. I can substitute this value at the formula of this u, that's a 1.6 minus 2.2 divided by 0.4. So what is the answer of this? It's a 0.6 over 0.2. That's a 1.5 is the right answer. It's a minus 0.6, 1.5. Then how you can write the backward difference formula? That is my fx. This is my x naught. This is my x1. This is my x2. This is my x3. So my target is to write the y3 plus the first backward difference, that is the u nabla of y. For the second, it's a u plus 1 over 2 factorial plus, because now this time is a 3 also, so u plus 1, u plus 2 divided by 3 factorial of nabla q. Fine. Now I can substitute this value. I can use the last line. Fine. So what is the value of the y3? Y3 is my 6.5. U is my minus 1.5. What is the del of y? That is this quantity. The last value is 0.54. Similarly, what is the value of this value? It's a minus 0.6 and the last value is my minus 0.41. Now you can solve this value with the help of the calculator. You will get the right answer as 5.439375 is the right answer. And you can also check your answer in the examination. Since 1.6 lies in between them, so your answer is also lies in between them. Look at the third example. The population of the time is given as this manner. Your target is to estimate the values at 2016. So clearly say which is lies near to the end of the information. Fine. Also, you can see this is my difference is 10, 10, 10, 10 and 10. They are equal distance. So we can use the backward difference formula. So my first step is to compute this table. Can you find the difference of this? It is my 20. You can find the second difference, 61 minus 66. So that is my 15. Next one, 93 minus 81 is my 12. Then you can find the last difference. Since they are not same, then I can find the second divided difference. Difference of them is my minus 5. Difference of them is my minus 3. Difference of them is my minus 4. Again, you can see they are not same. Then I can compute the del cube y. What is that answer is my 2. This answer is minus 1. Again, you can see they are not same. Then I can compute the del 4 of y. That will be my minus 3. Now, since the last number is my constant value, so now my target is complete of this. Can you find the value of the u? X minus xn over h. What is the value of the x? Your target is to find the values at 2016. Xn, that is the last number. 2022 divided by h, the difference is my 10. So what is the value of the h? this will be my minus of 6, 0.6 is the right answer. Now we have up to the del 4. I can use the backward difference formula, u plus 1 over 2 factorial, 3 factorial, and so on. Again, I can consider the last line because we are using the backward difference formula. What is the value of the, because this is the x naught and last one is x4. The first number is my 101, u is my minus 0.6. What is the nabla of u? This is my nabla, the value is my 8 minus 0.6 plus the x number is 0.4 for this value. Del cube y is my minus 1, del 4 is my minus 3. Now you can solve this value with the help of the calculator. You will get the right answer is 96.8368. Why I have written this in the thousand? If you look about the statement, the value of the fx is given in the terms of thousand, and you can see my answer must lies in between 93 to 101, and you can see it lies also in between them. Okay, can you find this value of this? I will give you the exercise for you. You can solve this problem and let me know your answer in the comment box so that I can understand that you can solve this problem. Look at this next problem. How you can find the value of the 10.26 from the given table. Again, clearly says that the 0.26 is lies end of the information. Fine. Also, you can see the difference is my 0.05, which is uniform. So I can apply the backward difference formula. Then your step number 1 is you need to complete the difference table. So let me know what is the answer of this. You can use the calculator or otherwise you can subtract it manually. So this will be my 8050.0, 0.0508. Similarly, you can subtract the second and you can solve. Clearly say these numbers are my not constants. So I can find the next number, that's a 0.0516 minus 0.0508. So it's a 8000. The first number is 0.0008. Similarly, you can subtract these quantities. You can write this quantity and so on. Again, you can see the quantities are not constant. I can find the del cube. You can subtract them. It will be my 0.0002, 0.0004. Again, they are not same. I can find the value of the del 4 of y. That will be 0002. Since my numbers are my constant, so I can stop. Can you find the value of the u? X minus xn divided by h. What is the value of the x? Your target is to find the values at 0.26. What is the value of the xn? The last number 0.30. H, what is the difference is 0.05. So what is the answer of this? That will be given you as a 1 is the this one. So 0.26, 0.30, that will be 0.04 divided by 0.5, that will be minus 0.8. Now I can use the backward difference formula. I can again I can use the last line. Fine. This number is my x0. This number is my x1. This number is x2. This is x3. This is x4. The corresponding value is my y4. So I have written this is y4. I can substitute these lines at the given values, and the value of the u is my minus 0.8. So after the calculation, you will get the answer as minus plus 0.2662, and clearly say 0.26 is lies in between them, and your answer is also lies in between these answers. So that's the correct answer. Look at this another category. From the following table, estimate the number of the students who obtained the marks between 75 to 80. Remember students, in all these previous example, our target is to find the values at the single point. Fine. All those examples we have discussed so far, we have to find the values at the single point. Now, in this case, we have to find the values in the range. Fine, as per the statement. How you can find that? Again, very simple. Before writing the difference table, what is the meaning of this statement? If I say what is the number of the students who are lies between the 75 to 80, so if I found the number of the students whose marks is less than 80, if I found the number of the students whose marks is less than 75, and if I subtract them, what will happen? If you subtract them, what is the meaning of that? We will get all those students whose marks are lies between 75 to 80, and that's why I have written this number y of 80 minus y of 75. What is the meaning of the y of 80? That means the number of the students whose marks is less than 80. So can you find from this table how many students are there whose marks are less than 80, or how many students whose marks is less than 75? Can you say this is the number of the student whose marks less than 75? No. This is the number of the students whose marks lies between 65 and 75. How many students whose marks is less than 75? That is this quantity. If you add them, that is the number of the students less than of 75. So that means I need to firstly found the number of the students whose marks is less than 45, 55, 65, 75, 85. How many students whose marks is less than 45? 20. How many students whose marks is less than 55? That is the cumulative. 60. How many students whose marks is less than of? It's a 120, and so on. Fine. So can you say how you can find the y of 80 minus y of 75? So your target is to compute the values at y of 80. Now again you can see this is my single number. Once this is a single number, then we can apply the Newton backward difference formula. And again you can see the difference is my constant. So what you can do, you can write the Newton's backward difference formula on this table. Now find the first difference table. That's a 40, difference is 60, difference is 60, difference is 20. All the values are not same. I can find the second difference table. 20, 0, minus 40. Again you can see they are not same. I can find the third difference table, until unless you will get the constant value. This number is my minus of 20, this number is my minus 40. Again they are not same, then I can find the fourth divided difference table. Now you get a constant value, so we will stop at this point. Can you find the value of the u? That is a x minus xn over h. What is the value of the x? Because my target is to find the values at the point 80. So x is my 80, xn is the last number, difference is my 10. So the answer is minus 0.5. Then again I can use the last row. I can substitute this value in the Newton divided difference. This is my x naught, this is my x4. The corresponding value is my y4. I can substitute the value of the y4 as a 200, nabla of y, that is my 20, then minus 40, and minus 20. After the calculation, you will get the answer as 198. What is the meaning of that? That means the marks obtained by the student less than of 80. Now once you know the number of the students whose marks are less than of the 198, then I can substitute this value. It is my 198 minus y. What is the y of 75? It's a 180. Because the number of the students are always integer, I can round off them to be the 198. Remember, this is the number of the students, and number of students are always integers. So what is the meaning of this? That means the number of the students whose marks lies between 75 to 80. That question you can do it by yourself. Again, you can see the similar kind of the question for your practice. Let me know your answers in the comment box so that I can understand. You can get your you can understand this lecture easily. Okay, look at this another question. Consider the table of this. Obtain the interpolating polynomial of degree less than or equal to 2. That means your target is to find the ax square plus bx plus c. That is a quadratic polynomial by using Newton backward difference formula. And hence you can find this value. So that means in this case, our target is to find the polynomial. Again, the first step is you have to complete the table. What is the nabla of y? If you subtract them, 6.6 minus of 3 is a 3.6 and so on. Again, the values are not same. You can subtract them. You can subtract, you can write the table. You can minus, you can get this number. You can subtract, you can get the minus 4. Again, the values are not same. You can find the del cube. But remember, there is no need to find the del cube because my target is to find the values of only degree 2. What is the meaning of the degree 2? You need to compute only up to the del scale. Fine. If they are not asking you what is the degree of degree, then you have to find the del cube, del 4 if needed. Now you can find the value of the u. Now for the first case, because x is not given to you, so I have used an x is my x. Last number is my h, xn, difference is my 1. So then I can use the Newton backward difference formula up to the second degree. What is the y for? That means I have to use the last pair. 25, u is my x minus 7, nabla is my 3, u is my x minus 7, u plus 1, that is the x minus 6 divided by 2 factorial of minus 4. Now you can open this bracket. Once you open this bracket, you will get the polynomial as this. And you can easily check your answer in the examination. How? If you take x is equal to 3, if you substitute at 3, that means it's a 9 plus 29 into 3 minus of 80. If you solve this calculation, you will get as answer 3. That's the same of this. Now, the next part is your target is to find the values of the 5.5. You can substitute this value 5.5. After the calculation, you will get the required answer. Use the backward difference formula, find the sixth term of this series. Remember, in this case, the table is not given to you. Fine. So again, that's a very simple. I can write this as a y because x is not given to you. So I can choose the value of the x is 1, 2, 3, 4, 5. Or it's on your choice. You may choose the value of the x as a 0, 1, 2, 3, 4. Fine. So your target is to find this sixth quantity. That's on your choice. So I can choose as a 1, 2, 3, 4, 5. The first difference 6. It is my, what is that, 20 minus is 11. It is my 18 and then so on. Again, the difference is not same. I can subtract them 7 and then 9. Again, the difference is not same. I can find the del cube. That is my 2 and 2. Now you can see they are same. I can stop them. What is my u? X minus xn over h. My target is to find the sixth term. So x will be my 6. Xn will be my last quantity. 5 divided by h is my 1. So xn will be my 1. Remember, if you take x is my 0, this is my 1, 2, 3 and 4. Fine. Then your x will be, your sixth term will be 5. Fine. Your xn will be 4. Then again you can see u is my again 1. Then I can use the third difference table, substitute this value by using the last here. So this number is 65. U is my 1 into 27. U is my 1 into 2 over 2 factorial of 9. This is the 1, 2 into 3. 3 factorial of 2. Now you can solve this value. It will be cancelled out. 3, 6 cancel out. So that's a 65, 27, 9 and 2. After the calculation, you will get as 103. Look at this another example. This is the exercise for you. You can see Lx is the number of the person lying in the A's. You can write this in the form of the table firstly. X, X is my subscript 20, 30, 40, 50, and the value of the Y is my 512, 439, 346, 243. Fine. So you can write this, and in this case your target is to find the polynomial. So you can take an U is in terms of the X. Then you can write the it. I hope you can enjoy this session too. You can share this video with your friends. Best of luck, students. Happy learning. All.